Hello again everyone, welcome back to ptet.chemistry channel. So this is the start of this section B type of questions, which is to do with just these three statements in every questions. And the combination is that 1, 2, 3 are whatever they want, correct, I guess. There is option A, 1 and 2 are correct, there is B. 2 and 3 are correct based on what they want, there's C. Only 1 is correct, there's D. Okay, so topic 7 is this is just my classification of reaction kinetics, and reaction kinetics is basically just a fancy term for rate of reaction in a chemist kind of lingo. Okay, so you have seen in the section A type of question on rate of reaction that Maxwell-Boltzmann distribution is a very a common type of question being asked, and it's not surprising therefore in this first question of this topical series that we see a Maxwell-Boltzmann distribution. Okay, so you should know that energy is on the x-axis, and then we have activation energy there. If you have a catalyzed reaction, you will have a new lower activation energy. But this question is not going to ask you anything on catalyst. So if I just look at what they want is as temperature increase, which statements are correct. Okay, so the whole idea of having the paper to write on is that you do your scribbling, you do your working, you underline what's supposed to read, so that you are not tricked by the question, hopefully. Okay, because you only return back the answer sheet, you don't return back the question paper, right? So please don't please don't make your paper so neat and clean. You gotta write stuff down, otherwise it's very difficult to just think everything in your head. Yeah, okay. So the proportion of molecules, if I just check statement 2, the proportion of molecules with energy above any given value increases. So I gotta think about what happened when temperature increase. So you can probably see that it goes down a little bit. So that is what happened when temperature increase. So you have increased the area under the graph. In addition to that bit originally, you have increased the proportion of molecules having energy greater than or equal to EA. Okay, so that is correct. All right. Hang on. Above. I am not very happy with the term. You see, a lot of them is playing around with words. Yeah, any given value. So for this value, yes, they are above, but the proportion of molecules with energies above any given value. If this is the given value, well, it has gone below, right? So the proportion of molecules with energy greater than that has gone below. Having thought about it, that is actually fine, because above any given value means the whole graph will shift to the right, so you will always have more molecules having energy greater than whatever given value is. Okay, so it's not just looking at the area specifically, but it's also looking at the you see how all of this has gone down because the whole graph shifted to the right, so you have more molecules that have higher energy. That's the idea to think about 2. So 2 is actually fine, 2 is legit. Okay, the maximum of the curve is displaced to the right as temperature increase, so that is correct. The proportion of molecules with any given energy increases. All right, so I think I was confused between this statement and this statement. Okay, this statement is saying that if you are here, your proportion of molecules greater than energy E definitely is higher as temperature increase. Okay, but the proportion of molecules with any given energy, this is just any given energy, whereas previously was above any given value. Any given energy will increase. That is not true, because if you think about there, okay, initially you have this much proportion of molecules with this energy, okay, at lower temperature. Now when you go to higher temperature, you have only this much. So your area under the graph, your proportion of molecules having energy of this value would have been lower when you go higher temperature, because the whole graph shifts to the right. So you see, they actually bolded that. Okay, so 3 is actually incorrect, and therefore only 1 and 2 is correct. Okay. With this next question is on catalysis, so properties of a catalyst. A catalyst does increase the rate of forward and backward, okay? So a catalyst doesn't just increase the rate of forward reaction, but also the backward or the reverse reaction, okay? A lot of students are confused about this. A catalyst increases the average kinetic energy of the reacting particles. That is incorrect because only temperature affects kinetic energy, okay? So only temperature can affect the kinetic energy, which is the Maxwell-Boltzmann distribution. Any other factors, they don't change the shape of the Maxwell-Boltzmann distribution at all. Since number 2 is correct and number 1 is incorrect, you can only be left with one choice, which is 2 and 3 are correct, okay? So given all that, 2 and 3 are correct, so there will be option C, okay? So catalysts will not have any effect on enthalpy change because catalysts affect kinetics, which is to do with rate. Enthalpy change is to do with thermodynamics, and rate and thermodynamics are not the same thing. In this next question, so we know that activation energy can only be affected by the presence of a catalyst because when you change temperature, your original EA does not change at all because you are only changing the distribution. So that is the number of molecules with energy E. You have energy E there. So if I have that, that is very bad actually. So I was supposed to draw a dotted line. So that is your EA uncatalyzed. If I have a higher temperature, I will shift that graph to there. But the original EA, which is for the uncatalyzed reaction, will remain. Okay, so the only thing that can change the value of EA will be if you have a catalyst, then you have a new lower EA, which will be catalyzed. Oops, better write that properly. But does that mean that your original activation energy changes? It doesn't. It is still there. It's just that now you have an alternative reaction pathway for the catalyzed reaction. That's what catalysis is all about. Yeah? So 2 is wrong. And in fact, you know, only catalyst can change or can give you a new lower activation energy. None of the other conditions will give you any changes in the value at all. That means the only answer is D. This next question is about activation energy again, but it's not asking you about the value. It's, if you check option 2, a reaction that takes place slowly. So a slow reaction will mean high activation energy barrier. It's to do with kinetics, okay? So it is not low, it is high. Only when you have a high activation energy, then your reaction will take place slowly. Number 2 is incorrect. That means only 1 is correct because based on the options, if number 2 is incorrect, only 1 must be correct. If we just check, activation energy of a reaction is different for forward and backward in an exothermic reaction. If I have a reaction profile diagrams, I will have energy. I will have progress of reaction. So different kind of graph, different axes. And you have an exothermic reaction. So you have your reactant. And then it goes to product. From your reactant to your product, the enthalpy change is exothermic. That's why it goes down. Your reactant lost energy to the surrounding. And your product will have lower energy than the reactants. So if I draw in a different color, this is the activation energy of the forward reaction. That is from the reactant to the top of the peak. If you have the backward reactions, that means you're going from product to reactant. So you have to go through via this top peak. We call it the hump. So from the product energy level to the top of the peak, that is the activation energy of the reverse, or you can call it the backward reaction. And clearly you can tell the magnitude is different, all right? So it is different, okay? Activation energy of a reaction unaffected by the presence of a catalyst, that is wrong, because we know that a catalyst can give you a new lower activation energy. and they give you alternative reaction pathway for your reaction to happen a bit faster. This is the last question of this 5-question series on section B type of questions of rate of reaction. So Maxwell-Boltzmann distribution. So which of the factors that affect the rate of reaction can be explained, okay, using a Maxwell-Boltzmann distribution? So Maxwell-Boltzmann distribution shows the distribution of energy for the molecules. If we increase temperature, this graph will look like that. So that is what happens as temperature increase. Your graph will shift to the right, it will skew to the right. You have more molecules that have higher energy, you have lesser molecules that have lower energy. So increasing temperature is correct. If number 2 is correct, you have to check number 1 and number 3 as well. Yeah? Increasing the concentration of reactants has no effect on Maxwell-Boltzmann distribution. Then how does increasing concentration of reactant increase rate of reaction? That is because it only affects collision frequency, something you learn a lot in O-level or GCSE. You don't talk about Maxwell-Boltzmann, you simply talk about collision frequency, whereas in A-level, we supplement your knowledge on explaining rate of reaction, especially temperature. We supplement it by invoking the idea of distribution of energy and relating temperature to the average kinetic energy of the reacting molecules or reacting particles. That is how you explain it in the theory paper. You can watch the topical playlist on some of the rate of reaction topics from AS to see how I explain it. Okay, so 1 is definitely wrong. And then addition of a catalyst, as I mentioned in the previous question, this would be a EA uncatalyzed, for example. So when you use a catalyst, you are going to have a new lower activation energy when you use a catalyst. So using a catalyst does affect the activation energy of the reaction, and it will affect the proportion of the effective collisions, and therefore it will affect the Maxwell-Boltzmann distribution as well. So that is correct. Only 2 and 3 are correct. That's option C. That's the end of this 5-question series. So don't forget to subscribe if you enjoy these videos, and check out other great playlists on my channel as well. They cover everything from GCSE to all the A-level topics. That's from 14 to 18 years old. Sorted out by topics, so whatever curriculum you're doing, doesn't matter if it's not GCSE or A-level, the contents within should be relevant to your learning of chemistry as well, wherever you are. Okay, thank you for watching. I'll see you in the next video.